Variations in consciousness. In this lesson, we'll be looking at the sleep and wake cycle. We're going to start with defining sleep. Sleep is defined as a state of consciousness with reduced awareness and variations in physical and mental activity. When you're asleep, you don't lose complete consciousness. Otherwise, we'd never be able to wake anyone up. When you are asleep, it's not a constant state, but you cycle instead through a series of stages. Now, as we discussed in the previous lesson, we've identified 4 key EEG brainwave or consciousness states. At the top, we have beta waves, which is hopefully what everybody is in as they're watching the video, reading the textbook, taking quizzes. Anytime you're engaged in learning, you should be in beta. If you want to go to sleep, you cannot be in beta. You have to first transition to alpha. Alpha brain waves are the brain waves you have when you're daydreamy and drowsy. So you start off laying down to go to sleep in alpha. If you are in alpha when you lay down, you should go through stage 1 sleep in anywhere between 1 to 7 minutes, 10 minutes. If it gets beyond 10 minutes, then you've probably not done a good job of putting yourself in alpha before you laid down. So this stage 1 is just a brief transition from alpha brainwaves to theta brainwaves. One of the things that sometimes happens during this first stage of sleep is people will jerk. And so you may have had this happen before where you actually jerk yourself awake. Sometimes it's experienced like a sense of falling. In this particular stage, you're very easily awakened. After stage 1, we typically transition into stage 2, which is another transitory stage of sleep. It lasts anywhere from 10 to 25 minutes, and the EEG pattern is characterized by sleep spindles, or these high-frequency bundles of waves in the EEG pattern. And this is essentially when people are transitioning from theta down into delta. From there, we go down into stage 3 and 4, which is our deep, slow wave sleep. You spend about half an hour here. And as you can see on the EEG patterns, the waves are very deep and they occur less frequently, so they are deep, slow wave sleep. This is when you are the hardest to wake up, and this is the most restful time of sleep. Now, what typically happens in a night is you lay down and go through stage 1 into 2, down to 3, down to 4, and then you cycle back up to 3 and 2, and then sometimes 1. But when you get up to the top during the night, sometimes you also enter the stage of REM sleep. REM sleep is called rapid eye movement sleep because this is the sleep where your eyes are moving rapidly underneath your eyelids. This is really easy to see in young children since their eyelids are so thin. And if we look at the EEG pattern and you look at the examples above, what you're going to see is that this particular EEG pattern looks an awful lot like your beta awake brain waves, and this is the time in which people report dreams. So let's look at the cycle over the course of the night. So over the course of the evening, you're going to lay down to go to sleep when you are in your nice, drowsy, alpha level brainwaves. You're going to go down to stages 1, 2, 3, and 4. And then you're going to come back up. Only when you get to the top, you're going to go through one of those periods of REM where the eyes are moving a lot and you have lots of dreams. Now notice that the first stage 4 deep slow wave of the night is relatively long. As we go throughout the night, these stages get shorter and shorter, and towards the end of the night, you don't even go down into the deepest stages of sleep. Should also notice that the very first REM of the night is relatively short, and the very last REM of the night is much longer. So REM gets longer over the course of the night, and slow wave gets shorter over the course of the night. It's also not uncommon for people to wake up during the night. Most of these awakenings last just a few minutes. You get up, you go to the bathroom, you get a drink, you roll over, you look at the alarm clock, resituate your pillow, you go back to sleep relatively quickly. So about every 90 minutes throughout the night, we're going through one of these cycles of sleep. When I cover this topic in my face-to-face class, I typically show a portion of the video from Frontline called Inside the Teenage Brain. I show the chapter on From Z's to A's. This has an example of a sleep study done with 2 different teenagers, and you get to see what happens when people miss out on different stages of sleep. I cannot show you that video within this video, and I also can't put that link in the YouTube playlist, but there is a link to the PBS video on our Blackboard page. So one of the things about sleep is that it changes over the course of your life. How much sleep you need changes, and the quality of your sleep changes. So one factor that affects this is age. If we look at newborn babies, they sleep a lot. On average, 16 hours a day. Unfortunately, those 16 hours usually occur in only an hour 2 or an hour there, not in a nice 8-hour chunk of time, which would be really great for their parents. In adulthood, we see that we get around 8 hours of sleep, but that the amount of sleep we need decreases over the course of the lifespan. So when most sleep we need is when we're newborn, and then it sort of decreases over the course of childhood. Then in adolescence, we hit a little bit more of a need for sleep, and then throughout adulthood, it's pretty much the same. The other interesting thing about sleep and aging is that newborn babies spend about half of their sleep time in rapid eye movement sleep. We think that this serves a couple of purposes. One reason why they spend so much time in REM is that they sleep so much, and if their brain was not getting some sort of stimulation or activity along those neural pathways, the neural pathways would shrivel up and prune. And at this point in life, we need them to grow. And the thing that makes a brain grow is activity. And so we think that part of what's going on with all this REM is just keeping the brain alive and stimulated. We also think that REM has something to do with learning and memory. And so we think that newborns are learning lots because they don't know anything, and so they need lots of REM. As we get older, we get to where we're spending about 20% of our time asleep in REM, and that stays pretty consistent after puberty. But the reason why our total sleep decreases after puberty is because we start to spend less time in slow wave sleep. Slow wave sleep is the sleep that's thought to be when we release the most human growth hormone. It's the most restorative, and so this may be one of the reasons why we are aging, is because we're getting less and less slow wave sleep. Another factor that affects our sleep is our culture. And what we see is that around the world, if we look at all different kinds of cultures, for the most part, we all get about the same amount of sleep, only tiny variations, and we all get about the same quality of sleep with only tiny variations. But there are some cultural variations in sleep. One, it has to do with napping. What we see is that cultures in hot climates, particularly those near the equator, tend to have a cultural tradition of napping or siesta, whereas our particular culture doesn't really have a napping culture. So in the US, we don't have nap time in the middle of the workday. You don't get nap time in the middle of your high school or your college classes. We do accept naps for children, people who are ill, pregnant women, the elderly, but as a group, as an entire culture, it's not a part of our sleep patterns for everyone. Another cultural variation in sleep has to do with who or what you sleep with. So in some cultures, entire families sleep all together in the same bed. In some cultures, people sleep with their animals. Some of you may even sleep with a dog or a cat. And we know that who or what you sleep with can affect the quality of your sleep. Now, what happens if you don't get enough sleep? Well, essentially, you get dumb, dumber, and dead. So if you have partial deprivation, or what we call sleep restriction, what that means is you're not sleeping enough during the night. And what we find is that lack of sleep is associated with impaired attention, slowed reaction time, poor muscle coordination, and poor decision making. People are much more likely to be in accidents if they haven't slept well. In addition, a whole host of health problems to include obesity, diabetes, hypertension, and coronary or heart disease have been associated with lack of sleep. But what may be an even bigger problem is too much sleep. So we see a really high rate of death associated with 5 or less hours of sleep a night and greater than 9 hours of sleep a night. Now, some of this may reflect the fact that people who are ill sleep more than others. You can also have something called selective deprivation. In selective deprivation, you're missing out on a particular type of sleep, either REM sleep or slow wave sleep. And these two types of sleep seem to be critically important because if you miss out on REM tonight, the next night you'll experience a rebound effect in which you will spend more time in REM early in the night, almost to kind of make up for it. And the same thing happens if you miss out on slow wave sleep. People who have selective sleep deprivation have impaired memory consolidation, so their memories are not very good, and also impaired neurogenesis. They can't create those neural connections. And we also see that they're not as creative. Of course, the last issue here is going to be complete deprivation. So in complete deprivation, you don't get any sleep at all. We think that you can maybe go 3 or 4 days max. If you go longer than that, it can actually be lethal. Unfortunately, we have not been able to do controlled experimental studies to find out exactly how long you can keep someone up before they die. What we do know is after a couple of days, you start entering into what are called micro sleep states, where you can't quite control going into a state of altered consciousness. And this is why some people will say they've stayed up for a week or more at a time without sleeping. It's because they were going into these micro sleep states without even being aware of it.